All right, for this lesson, we're going to look at another very important differentiating toolkit, which is the quotient rule. Whenever you have a function divided by another function, how do you find its derivative? So in other words, if I wanted you to find the derivative of f of x divided by g of x, well, the rule is the derivative of f of x divided by g of x would be g of x times the derivative of f of x minus f of x times the derivative of g of x all over g of x squared. Another way of thinking about it is this expression, low d high minus high d low all over low squared. That's another way of thinking about it. So, for example, if I wanted you to find the derivative of, let's say, x plus 2 over x minus 3, the derivative would be low, for the low function, x minus 3, low, high, the derivative of x plus 2 would just be 1, minus high, which would be x plus 2, times the derivative of low, where the derivative of x minus 3 would just be 1. So low, high minus high, low, all over low squared. Of course, we would clean this up, but that's the gist of the quotient rule, is low d high minus high d low all over low squared. So let's look at another example. Let's say if I gave you the function x over 1 plus x squared, let me clean that up, 1 plus x squared. So the derivative of this would be low, so 1 plus x squared, times the derivative of high, low d high, so derivative of x would just be 1, plus high d low, and the derivative of 1 plus x squared would just be 2x, all over low squared. And I could just clean the numerator up. That would give me 1 plus x squared plus 2x squared over 1 plus x squared squared, and then that would just give me 3x squared plus 1 over 1 plus x squared squared. And that would be the derivative of that expression. So low d high minus, I put plus. Let's change that to a minus, so that needs to be minus, not a plus. Let me change that right quick. So this should have been a minus, so let's put a minus sign. So then that will be 1 plus x squared minus 2x squared, and x squared minus 2x squared. Then this will be negative 1x squared. So that would be negative x squared plus 1 over 1 plus x squared to the second power. So there we go. Just remember, it's low d high minus high d low all over low squared. All right, look at another one. So if I ask you to find the derivative with respect to t of e to the t over e to the t plus 1, we can find the derivative of this very quickly. The derivative of that would be low, so e to the t plus 1. D high, the derivative of e to the t is just e to the t, minus high, so e to the t, low, and the derivative of e to the t plus 1 would just be e to the t, all over low squared. Then I could just clean this up. If I clean this up, I would get e to the t times e to the t would be e to the 2t plus e to the t minus e to the 2t over e to the t plus 1 squared. The e to the 2t's cross out, so that just leaves me e to the t over e to the t plus 1 squared. So I got low d high minus high d low, high d low, all over low squared. Let's try another one that's similar to that. Let's try the one that I actually want to do. This is the derivative of t. If I tell you e to the t over e to the t instead of plus 1, let's make this plus t. That makes it a little bit more challenging. And this is actually the problem that I wanted to do. So let's do it again. So we're going to have low, so e to the t plus t, d high, So that would just be e to the t, minus high, which would be e to the t, be low, and the derivative of the low would just be e to the t plus 1, all over low squared, and then I can clean up, distribute in the numerator. Again, I would get e to the 2t plus t, e to the t, distribute in the numerator. Again, I get e to the 2t plus e to the t, e to the 2t's cross out, so that just gives me p e to the t plus e to the t over e to the t plus t squared, and then I notice I could factor out an e to the t in the numerator, so I take out that e to the t, it leaves me t plus 1 over e to the t plus t squared. And that would be the answer that I was looking for that problem. All right, let's look at one more. For this one, it wants you to, let's say if I wanted you to find the tangent line. Well, remember, in order to find the tangent line, you need two things. You need to know the slope and the point. In the context of this, the slope will be my derivative. So here's my function. F of x is equal to 3x squared plus x minus 2 over 4x cubed plus 1. So I want to find the equation of the tangent line of this function at x is equal to 1. Well, first of all, I need to know the point. So my point is going to be xy, so it would be 1 comma, I don't know what the y is, but I can find out y by plugging the 1 into the function. So if I plugged in f of 1, I should get 3 plus 1 minus 2 over 4 plus 1, so I should get 3 plus 1, 4, 4 minus, which I should get 2 over 5. So then that y value is 2/5. So there's my point. Now to find my slope, I need to find the derivative. So let's take the derivative of my function. So my derivative would be low, so 4x cubed plus 1, d high, which would be 6x plus 1, minus high, d low, which would be 12x squared, all over low squared. And I'm not even going to try and clean this up because all I want to do is find the slope at the point 1. So let's just simply plug in 1 into the derivative. And so I'm going to get 4 plus 1, so that'll give me 5. 6 plus 1, that'll give me 7. Minus 3 plus 1 is 4. Minus 2, so that'll be 2. That'll give me 12 over 4 plus 1, that'll be 5. So 5 squared. And then clean this up, so I get 35 minus 24 over 25, so that gives me 11 over 25. And so there's my slope, 11 over 25. And let me make this here again. There we go, 11 over 25. So now I can write my equation of the tangent line. It would simply be y minus 2/5 equals 11 over 25 times x minus 1. And that would be the equation of my tangent line for this function at the point x is equal to 1, y is equal to 2/5.